last two problems on this sheet. So now I know this is a parallelogram, so that kind of tells me things are parallel, things are congruent. They say OH is perpendicular to GK, so I can draw a little right angle there, right? And I know these are parallel because it's a parallelogram. And they also tell me MK is an altitude of this triangle. Well, if it's an altitude, that's a then that's a right angle. So angle K is, I can just say measure of angle K is 90 degrees. Definition of altitude. Right? That's what altitudes do. They go 90 degrees to the thing. Okay, now I need to prove that this is a rectangle. Well, I can tell you right now that if this is 90, then this has to be 90, because angle O is 90. Measure of angle O, that looks like 0. Why is that? Same side interior angles are supplementary. So that has to add up to 180. You could say, if you want to do this very algebraically, if I had more room, the measure of angle H plus measure of angle O equals 180. You already know that's 90, so that means the measure of angle O has to be 90. Same thing for this one. The measure of angle OMK, and I really need to specify there because there's several choices. So that angle is 90 by the same reasoning. All right. Well, opposite sides are parallel, and I have all right angles. So how do I know that these two are parallel? Well, if we have a transversal that's perpendicular to two lines, then the two lines are parallel. OH is parallel to MK, right? Because transversals, if transversal is perpendicular to two lines, then lines are parallel. We learned that a long time ago, all right? Okay, so now I know these are parallel, so I can definitely say this is a parallelogram. It's got right angles in it. Oops, I'm sorry. It's a parallelogram. Here was where I wrote this, the transversal. It's got right angles in it, and therefore it has to be a triangle. OMKH. I'm sorry, a triangle, a rectangle. That's like my kids who said, it's a square. All right, that's because opposite sides parallel, so it's a parallelogram. And all corners are right angles. All right angles. So those two things make it a rectangle. Last but not least, we have AC bisects angle bad. All right, so that means this angle has to equal that angle. All right, AB is congruent to BC. Aha, what that means is that angle BAC must be congruent to angle BCA. Why is that? Well, I have an isosceles triangle right here. Base angles are congruent. All right? And let's see. They tell me that these two are not parallel. Okay, all right, so AB is not parallel to CD. Now, can I prove that BC is parallel to AD? Well, you see these two angles right here? Those are alternate interior angles. So BC has to be parallel to AD because of alternate interior angles being congruent. All right? And if I have parallel bases and then a set of non-parallel sides, that means this is a trapezoid. And I wimp out and I say, definition of a trapezoid. Because I proved that only one set of lines is parallel. One set of sides is parallel. The other sides are not parallel. It's a quadrilateral. It has to be a trapezoid.